Hello everyone. In this video I am going to show you how to draw shear force and bending moment diagrams, and this is the example 1. First we have to know support conditions. So you can see here these are the notations, and this column these are support condition name, and these are the forces. So first one is pin support. So this is the pin support notation, and if we have a pin support we mark two force components, one horizontal force component and one vertical force component. Second one is roller. This is the notation of roller, and if we have a roller support we mark one vertical force component. And third one is simply supported. So if we have simply supported support condition we mark one vertical force component. If we have a fixed support we mark three components, which are two force components and one moment components. So you can see in this diagram there are three components, Fx, Fy and M. M is the moment. So this is our example. So I am going to draw shear force and bending moment diagram for this beam. So you can see there are two support conditions. At A there is a pin support, and at B there is a roller support, and there is a point load here 6 Newton, and distance between point A and this point load is 3 meters, and this length is 9 meters. So first we have to determine support reactions. So for that I have to mark support reactions. If we have a pin support we mark two force components, and if we have a roller support we mark one vertical force components. Now we have to find the values of this AX, AY and BY. First I am going to take the moment about A to the counterclockwise direction. So if I take moment about A, I have to consider this 6 Newton force and this By force. So moment due to this By force is positive because the moment due to this force is counterclockwise. So I wrote By here, and distance to A to B is 3 plus 9 is 12. That's why I wrote 12 here. And 6 Newton. Moment due to this 6 Newton force is clockwise moment. Therefore I put minus sign here because I consider counterclockwise direction. So point load is 6 Newton and distance to this force is 3 meters. So now I can simplify this and get the answer as By equals 1.5 Newton. Then I am going to take the sum of all the vertical forces. So if we consider vertical forces, I have to consider this AY force, BY force and 6 Newton force. But now I already know value of this BY force. AY is this force because I consider this upward direction, therefore I put plus AY, and also BY also plus because it is upward direction, and minus 6 Newton because 6 Newton is directed to the downward direction. Therefore I put minus 6 Newton here. And now I can substitute value for By. By equals 1.5 Newton. So I substitute it here 1.5 Newton, and then I can simplify this and get the answer as Ay equals 4.5 Newton. Then I will consider sum of horizontal forces. So there is a one horizontal force which is Ax, and therefore Ax equals 0. Now I found all the three support reactions. Now I can draw shear force diagram and bending moment diagram. So look at this diagram. You can see there are shaded line here, right? There are three shaded lines. We usually draw shaded lines in supports So there are two supports A and B, therefore two shaded lines. If we have a point load, we mark one shaded line, or we draw one shaded line through this point load. So our diagrams will be drawn in these areas. If I mark here as C, for the AC part I will draw shear force diagram here and bending moment diagram here. For the CB part I will draw shear force diagram here and bending moment diagram here. So next I am going to draw shear force diagram for this AC part. For that I have to cut this AC part, so I will cut through here. When I cut it, I can take it out. So you can see this is this separate part, right? So you can see support reaction and you can see point A. Now I am going to write the equation for this part of beam. So now I mark shear force. I mark shear force as V1. Why I mark V1 as this direction? Can't I mark it other direction for this direction? It's because of sign convention. So before we draw shear force and bending moment diagram, we have to state our sign convention. So my sign convention is I will consider clockwise positive and I am not consider this anti-clockwise direction. That means if I draw a part of a beam and suppose this is a support, I will mark force like this. The moment due to this force is clockwise direction. If I mark force this direction, moment due to this force is counterclockwise direction. So I am not going to consider this direction, I am consider clockwise direction. That's why I marked shear force as this direction. So this is the shear force, right? This sign convention for shear force clockwise positive. I am not consider this anti-clockwise direction. So this is the shear force. Then bending moment, I will consider sagging moment positive, and this sagging moment I am not going to consider. So this is bending moment. That means if I draw a part of a beam like this, I will mark moment as sagging. That means for sag this part of beam, moment should be applied in this direction. For then this beam is going to sag like this. If I apply moment other direction, this direction, this beam is going to deflect like this. That is hogging direction or hogging moment. So I am not going to consider this moment, I am consider this moment. That means sagging moment is positive. So now you know why I mark V1 as this direction. So next I am going to mark the moment here as M1. So V1 is the shear force and M1 is the bending moment. Now I am going to find the values of this M1 and V1. Actually it's not values, I am going to find equations of V1 and M1. Then I can draw graphs for those equations. So I mark this point as P and this length as X. So this X is marked from this point A, and please keep in mind I consider this part, right? I consider this part and I am going to draw diagrams for this part. X is valid for this range, and then I am going to take the sum of all the vertical forces for this part. So you can see for AP 4.5 Newton is this force, it is directed to the upward direction, and minus V1 because V1 is directed to the downward direction. Now I can write V1 equals 4.5 Newton. Next I am going to take the moment about point A. If I take moment, I have to write M1 because M1 is same direction we consider, minus V1 times X. That means moment due to this force. Force is V1, that's when I wrote V1. Moment due to this V1 force is clockwise. So I consider counterclockwise direction. This moment is clockwise direction, therefore I put minus sign here. Then I can write M1 minus 4.5 times X equals 0. You can see I wrote 4.5 here because V1 equals 4.5. I found it here. Then I can write a function for M1. M1 equals 4.5 X. So this is the diagram for moment. This is the diagram for shear force. So these all functions are valid for this region, right? A to this point. So how we draw graphs for this function? For that we have to know how to draw graphs. So look at this, V1 equals 4.5. So this is y equals C type graph. That means just a horizontal line, and this height is 4.5. or you can say this value is, this crossing point value is 4.5 on y axis. So this function, this is y equals mx type. That means this is a soft straight line through this 0 point, like this, and you can see m equals 4.5. that means slope of this straight line is 4.5. you can see here 4.5 is the slope of this straight line. So now I can draw these two lines in our shear force and bending moment diagram. So I write here 4.5 Newton, a straight line, a horizontal straight line. So bending moment, I write bending moment, I draw a straight line of slope of 4.5. So these lengths are given. This length is 3 meters and this length is 3 meters as well. So now I have to find value of this point. So for that I can use this equation or this statement. For that I can use this function m1 equals 4.5x. If I need value of this point, I just have to input this value for our function. That means if I need this value, I have to put x equals 3 for this function. So I will substitute it. When x equals 3, m1 equals 4.5 times 3. So it comes m1 equals 13.5. That means the value of this point is 13.5 Newton meter. So now I completely draw shear force and bending moment diagram for this segment, right? This colored segment. So next I am going to draw shear force and bending moment diagram for this segment. If I mark it here, see this CB section. So in order to find the shear force and bending moment diagram for this region, right, this region, I have to cut the beam in the location of like this. So now I can regrow it like this. So if I cut beam in this section, so I have to consider this whole part. So that's why I wrote it here. Now I will mark the X from this point, right? So I will erase other things and I will mark X from this point. So I clearly marked here. So you can see 4.5 is the support reaction, 6 Newton is the point load, and this 3 meter distance is given, and I marked X like this. And now I am going to mark shear force, and I mark this point as Q. So this is the shear force, I marked it, this V2. Moment due to V2 is clockwise direction, and M2 moment due to this M2 is sagging moment for this AQ beam. So as I did before, here also I am going to find V2 and M2. So for that I will consider sum of all the horizontal forces for AQ. So and minus 6 Newton, and finally this V2 force. So if I simplify this, I can get V2 equals minus 1.5 Newton. Next I am going to take the moment about point A. If I take moment about point A, I can write plus M2 and minus 6 Newton, minus because 6 Newton is other direction. I consider counterclockwise direction. Moment due to the 6 Newton force is clockwise direction, therefore I put minus sign here. 6 is the force and 3 is the distance between point A and this point load, and then minus V2. V2 is the same direction as 6 Newton, therefore I put minus sign here. V2 times 3 plus X, because we take moment about A, distance between A and Q is 3 plus X, so that's why I wrote 3 plus X. So now I can simplify this, and I can substitute V2 for this V2 value, and M2 minus 6 times 3 minus 1.5, this value times 3 plus X. Now I can simplify this, so you can see step by step calculation here. So finally I can get M2 as M2 equals minus 1.5x plus 13.5. so here also this equation for V2 and M2 are valid for this region, larger than 3 and smaller than 3, that is this region. You can't apply this graph, so these functions for this region, right? Only for this region, not this region. Okay, now I am going to draw graphs in this graph papers, and V1 equals minus 1.5. Here also this is just a horizontal line, and it crosses the minus 1.5 of X axis. So it is the type of y equals C. So this is the graph. This height is 1.5 and this value is minus 1.5, and here this is the type of y equals minus mx plus c. So you can see this is minus m, that means this is a negative slope. So this is this type of line. So this height is 13.5, right? And the slope of this line is 1.5, so it is minus 1.5. You can see the angle. So now I know shapes of graph, so now I am going to draw it here. This is the shear force diagram for this CB part, and this value is minus 1.5, and then I have to draw bending moment diagram for CB part. So for that I have to know starting point and ending point. So you can see there are no moments in A and B, so therefore bending moment diagram of this beam is starting from 0 and ending from 0. Therefore now you know this graph is end in this point. So, and these bending moment diagrams are continuous diagrams. So if previous diagram is ended it here, next diagram is starting from this point. So that means bending moment diagram is like this. So I will show you clearly, draw line. So like this. So if you want to check the values, you can input values. So as I told you before, I marked x from here, right? If you want to find the value of this point, you can substitute x equals 0 for this function. So if you input x equals 0, you can see m2 equals 13.5. And also if you want to check value of this point, you can just input the value of x. If x is going to this far, x equals 9. So if you want to find the value of this point, you can simply substitute x equals 9 and see what is the answer. If you substitute x for 9, you can find m2 equals 0. So that's how we draw shear force and bending moment diagram for this beam. So you can see if x is equals to 0, m2 equals 13.5, that is this value. And if x equals 9, you can get m2 equals 0, that means this value. So that's how we draw shear force and bending moment diagram for this beam. I hope you understood what I explained. Thank you.